Let's talk about one of the most incredible pieces of engineering on the planet. And guess what? You own two of them. It's your hand. We use it for literally everything, from the most powerful actions to the most delicate touches, and we barely even think about it. So today, we're going to dive into this absolute marvel of anatomy.
And that really gets to the heart of it, doesn't it? How can one single tool be so contradictory? It can be a hammer, delivering brute force, and then, a split second later, it can be like a pair of tweezers, with all the fine-tuned precision in the world. How is that even possible?
Well, it really boils down to two totally different jobs. You've got the power grip, think holding a baseball bat. You're using your whole hand, wrapping everything around it for maximum force. Then you've got the precision grip, picking up a tiny pin. That's all fingertips, all about delicate, controlled movements. The magic is in the anatomy that lets us switch between these two on a dime, and that's what we're going to unpack.
All right, first up, let's uncover some of your hand's hidden superpowers. We're going to peel back the layers and see what makes it all tick.
And everything, I mean everything, starts with the foundation, the scaffolding. We're talking about the bones, a framework that's way more complex and adaptable than you might think.
27. Just think about that number for a second. That's how many bones are packed into each of your hands and wrists. Now, that's not just for show. Having all those little individual parts is the secret sauce behind the hand's incredible flexibility and range of motion. And those 27 bones are organized into three key groups. First, you've got the 8 carpals down at the wrist, which create this really stable but still flexible base. Then, the 5 metacarpals fan out to form your palm, giving it that broad shape. And of course, you've got the 14 phalanges. Those are the bones that make up your fingers and your all-important thumb.
Now here's where the design gets really, really clever. Your palm isn't flat. The bones are arranged in curves, what we call the palmar arches. This design is what lets your hand instantly change its shape. It can go flat to push something, or it can cut perfectly around a ball. It's like having a dynamic scaffold that just adapts to whatever you need to grab.
Okay, so we've got the frame. Now let's talk about the engines that make it all move, the muscles. This is where that whole power and precision thing really comes to life.
You can think of it like two different teams. The extrinsic muscles are the heavy lifters. They're actually located up in your forearm, and they connect down into your hand with long tendons. They provide all that raw power for a strong grip. But the real artists, those are the intrinsic muscles. They live inside the hand itself, and they're responsible for all the fine, delicate, skillful movements.
And these little muscles in the hand are super specialized. You've got the thenar muscles right at the base of your thumb. Go ahead, touch your thumb to your pinky finger. Yep, that's them working. They're what make your thumb opposable. The hypothenar muscles do